In this fifth lecture on Fortran, we shall introduce the do loops. Do loop. Sometime a same operation has to be performed a large number of times. Say for example, each people of West Bengal are said to provide three numbers a, b, c, which stands for the coefficients of a quadratic equation like this: ax square bx plus c, and we need to calculate the value of the roots for each of these triplets of numbers. In an earlier class, we have learned how to find out the roots of a quadratic equation provided a, b, c are given. So once we set up this program, we need to provide first the value of a1, b1, c1. The corresponding roots will be evaluated. Again, another person will be asked to provide the values of a2, b2, c2, and again the roots will be calculated. So the thing is that the repetitive job has to be performed with the values of with the triplets of values of a, b, c. Such repetitive jobs are done by do loops. Let me take an example. That is, we need to calculate the average value of few numbers. Say there are n numbers, and we need to calculate this average value. So this runs from X. I have considered simple data, that is, there is no weightage. Weightage is 1 for all these data. So this is the formula. So what we need to know, we need to calculate is that first we need to know the value of n, and then we need to know the values of x. So n, say n is equal to 10, then we need to know x1, x2 up to x10, and then we need to sum this one. First problem that I am doing is that to read xi from I is equal to 1 to n and write them. Read this and then write this same. How to do it in computer, then I will come into this problem. So the first thing is to read few numbers and to write the corresponding number. The Fortran programming starts. First thing, read n, the number of data. Then we write. Let me first write, then I will explain. Do O, this is blank, I is equal to 1 comma do blank 10 blank I is equal to 1 comma n. It knows n beforehand, then it read. Now let me explain the fact. First the program reads the value of n. Say n is 10. Then it is introduced a dummy variable I, which runs from 1 to n. Because n is provided earlier, it will as first assume the value of I is equal to 1 because it is the starting value. Then it will assume I is equal to 2 and so on. So in the first step, it reads the value x1 and writes the value of x. Then it has been asked to continue up to statement number 10. So on reaching statement number 10, between 2 and 5, second and fifth column, it returns here and assumes the next value of I, that is I is equal to 2, and it reads x2 and writes x2. And this thing continues until it as I assumes the last value, that is last value is 10. Then on assume having this last value, it will not return to this statement anymore, but comes to this, and you write that stop end. So if we provide n is equal to 3, then what the program will do in the output, we first write the value of n is equal to 1, say 1.1, then 9.2, and then 2.4. So its first value will be assumed to be x1, then it is x2, and this is x3. So it first reads this 1.1 and writes it 1.1. Let me change one thing, let me do it simply 2. So it writes 1.1, then it is 9.2, and lastly it is 2.0. Because x is real, it puts a real signature on it. So this is the basic use of do loop. So let me now come to the general statements of a do loop. The general statement of a do loop is like this. General form of do loop. This is very powerful technique in computer programming. Do blank statement number blank dummy variable this is the dummy variable. It must be a integer, because whenever I say this sum I is equal to 1, 2, and I assumes integer value, that is to remind this I have written integer dummy variable. If we write x do blank 5 blank x is equal to 1, 9, then it will give you an error message or warning message, because x is not an integer variable. So this is integer variable, then it is its initial value. As for example, here the initial value is 1. One may write it from 5 to 8 also. Then it will be 5. This is the final value. And this is step. So for example, if we have an AP whose first term is 3, last term is less than 100, and common difference is 5, we need to generate the terms of the AP. Then the do loop will be 305. So what will integer this dummy variable first assumes the value 3, then 3 plus 5, because it is step. 3 plus 5 is equal to 8, then 8 plus 5 is equal to 13, and so on and so forth, and the final value will be less than or equal to this. As for example, in this case, the value is last value will be 98, and 98, the last value will be 98, and then from 98, if we want 5, this is 103, so this value will not be attained. The last term will be 98. Another thing can be done, it is if you used I have erased it by mistake. And this repetitive job will be continued up to the statement level 5. The statement level 5. As for example, here we have written 10, so it assumes the first value of I and do all the steps up to the statement number 10 and then returns over here and assumes the next value. If we consider this example, it first assumes the value of I, performs all this line, then comes over here and assumes second value of I as 8. If this step is positive, then the initial value must be smaller than the final value. If we write a do loop like this, I is equal to 9,5, then since step is nothing specified, it assumes steps to be +1. So it is not possible to arrive at 5 starting from 9 by adding +1. So the loop will not be executed. Entire this bunch will be off from the program. So we must take precaution of this. But on the other hand, this same loop could be performed with this. In this case, the value of I will be 9, 8, 7, 6, 5. Here in this case step is negative, and if nothing is specified in the for step, as in this case, it assumes steps to be +1. I will now consider another example which will be very useful for calculating sums in computer programming. So now I come to the program of calculating the arithmetic mean of a given number of data. Arithmetic mean is defined as when the data is not weighted 1, this is I is equal to 1 to n. So we know how to read the data. Now the next term is find out the sum. The sum is actually x1 plus x2 plus x3 up to xn. This is the sum. First thing is that if we write this sum in longhand, then there is no need of going for computer programming. The basic requirement of computer programming that I will provide clear instruction to the computer, and the labor will be taken, laborious job or the time consuming part will be done by the computer. So if I go on writing this, the first problem is that what is the value of n? You need to know the value of n beforehand. Say one performs the program for n is equal to 100, then one needs to write all these things. But if someone asks you to calculate the sum of 200 terms or average of 200 terms, then you need to write again 100 more terms like this. It is not a practical way of writing a Fortran program. So what we do? Let me explain this term. I first take a dump variable I, then know the corresponding value, then I write S final is equal to S initial. This is this X final xi, and beforehand I set S initial to be 0. So at the first line x is equal to 1, I read x1, and in this case Si is 0, so it writes 0 plus x1, which is x1, so that it assigns the value of xf to be 0. This. In the next step, I come to the value I is equal to 2, reads x2, and it finds for this the already then we do one thing, we interchange Si is equal to Sf. So what you get, Si is equal to x1. When we come to this step, it is x1 because I have redefined this, and adds x2, so SF is this SF. SF is this is SF is equal to 0 plus x1, that is x1, and so redefine its SI is equal to x1. These two s should be smaller case. In this case it is x2, so we have for s1 it is already x1, and then I write x2, so SF is equal to x2. In this case I get SI is equal to x1 plus x2. In the third step the input is x3, so SF is equal to this much. This is already x1 plus x2 and x3 is added to it, and then redefines SI to be x1 plus x2 plus x3. So in terms of mathematics, everything I am doing this example, SF is equal to SI plus XI, followed by the term that SI is equal to SF. Instead, we could do one thing. We could omit this subscript I and F on the summation, and we could write S is equal to S plus Xi simply. In terms of mathematics, this relation is valid only when Xi is 0. But I have stated earlier, this is not an equal to sign. This is the assignment sign. What one does for Fortran programming, it starts from right and calculates entire thing written prior to equal to sign, this assignment sign. So it calculates the entire thing, and the resulting value has been assigned to the quantity written on the left of the equal to sign. So if we do this in terms of x, so in this form the situation is this. Firstly, it assumes s is equal to 0 in this term, and then you write s is equal to s plus xi. In the first step, it writes s is equal to 0 plus x1. This is equal to x1. In the second term, it writes s is equal to, already the value of s is x1 and it adds x2 to it. So this is the value of x2. In the third step, it writes s is equal to, already the value of s is x1 plus x2, so it writes. So every time I perform the single operation. This is the very powerful technique in computer programming, and this has become possible only because of the fact this is not mathematical equal to sign, it is the assignment statements. So with this preliminary, let me calculate the average of n quantities, n data supplied. So first thing is read n, then we write s is equal to 0.0 as the data are real, so we initialize it to this. Then do blank 9 blank I is equal to 1 comma n, x, s is equal to s plus x, now come to the average value. A v of x is equal to s divided by I have already asked you the float program, and so write so here in the first step, when I is equal to 1, s has to be assigned previously. It has been set to 0, the additive identity. S has been set to additive identity. This is called the initialization. If you do not do this initialization, the program may give you wrong result. So in first step, s is 0, so it is x1, so the s is x1. In the next step, s is x1, so x1 is added to x2, so the result is x2. This operation is perfectly automatic. You need to provide the value of n only, and the sum will be continued to exhaust all the n values. You need not to add or subtract anything in the programming. It will be adjusted automatically. This is the one powerful technique of using do loop. Another example I am considering by using do loop is the calculation of factorial n. Factorial n is defined as this is the factorial n, and we know that factorial of 0 is equal to 1 by assumption, and factorial of negative integers are not defined. So our aim is to calculate the factorial of an integer number. Say the number is n, and I calculate the factorial. Since the factorial of an integer is an integer also, I write is I fac is equal to 1. This is then I write do blank I write, so this I fac in the first step. What it does, I fac is equal to 1, then 1 into 1 is 1. In the next step, I is 2, so it multiplies 1 with 2, it is 2. In the next step, it multiplies 2 with 3, so that is 6, factorial 3, and the process continues. Few precautions. If one assumes if one supplies the value of n to be 0, then this do loop will be from 1 to 0, 1 to 0, and this part will not be executed at all because it is 1. So this loop, this is not a valid do loop structure, so the part will not be executed. And IFAC is 1, so the result will be 1. It's okay. By chance we get the correct option. But what happens if somebody provides n to be -5? Then some precaution has to be taken. So I am left it for you. Take precaution. Precaution for negative integral values of n. And then I finally write write the value of n and I fac, then stop end. If you provide the value of n to be 10, factorial 10 is a huge number, you will find in your computer that sometimes it is this program does not give the correct result for n is equal to 10 or more. In that case, still some we can increase n by performing the program in real mode. In that case, this must be not be an integer, so we may I may replace I fac by fac. In that case, it will be 1.0, and this line will be fac is equal to fac star float I. In this case, if you find that your computer gives correct value of factorial for n is equal to up to n in this fashion and fails for n is equal to 11, then this writing this program in this fashion, you may find that the program gives correct value for n is equal to say 15, and it may fail for 16 onwards. In that case, some more precaution has to be taken, that I will come afterwards. So today what I have focused is the use of do loop, the do loop statement and its use.